Hello students, and welcome to you all in my online class. So today we'll do the topic inverse of a matrix, that is its application. In the last online class we did how to find out the inverse of a given matrix. So today we'll do application of this inverse of a matrix. That means how to solve given system of equations. Some equations are given, two equations with two unknowns or three equations with three unknowns, and you have to solve it with the help of inverse of a matrix. That is, that method of solving the given system of equation is known as matrix inversion method. Okay. Now, so in order to solve this given system of equation with the help of matrix inversion method, you have to know the basic things, how to convert the given system of equation into matrix equation. Okay. Now let us discuss about how to convert given system of equations to matrix equation, right? So here is the question: represent the following equations in matrix form. So this equation is given in terms of x and y, and some constant are there. Okay, so you have to convert this given system of equations into matrix form. So how will you convert it? So let us do number one. That is, the given system of equations is a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. Now this is equation in terms of x and y. So you have to convert it into matrix form. So always, in order to solve this equation, always you take the constant term which are free from x and y to the right hand side always. Okay, so it will be a1x plus b1y is equal to minus c1. Then next, a2x plus b2y is equal to minus c2. Okay, now let us assume the matrix A. The matrix A will be the coefficient matrix. That is, the coefficient of x and y should be here. That is, capital A is equal in the first row. So in the first equation, this is the first equation and this is the second equation. So first equation is a1x plus b1y is equal to minus c1. So let matrix A is equal to, you have to write down the coefficient of x and y from the first equation in the first row. Okay, so it will be a1, b1, and from the second equation, what are the coefficients of x and y? It is a2, b2. So you should write here a2, b2. Is that clear to all of you? So this is known as the coefficient matrix. This is known as what? Coefficient matrix, because in this case we have written the coefficients of x and y from both the equations 1 and 2. So in the first row, from the first equation, we have written the coefficients of x and y out here, that is a1, b1. And in the second row, we have written the coefficient of x and y from the second equation, that is a2, b2. Okay? And which are the unknown quantities here? That means you have to solve it. So in order to solve it, you have to get the values of x and y. So these x and y are unknown quantities. Let us assume it as, let capital X is equal to xy. This will be the column matrix. This will be the column matrix. Okay, and then on the right hand side there are two constants which are free from x and y, that is minus c1 minus c2. Let it be the constant matrix, that is also the column matrix. Let capital C is equal to minus c1 minus c2. This is also the column matrix. Okay, so now this given system of equation, now you can change it into matrix equation. How can you change it? Therefore you should write here A into X, A matrix into X matrix is equal to, what do you write? Is equal to C, where capital A is equal to this coefficient matrix, and where capital X is equal to, this is variable x and y, which is the column matrix, and C is the constant matrix, that is minus C1 minus C2. Okay, so again you can change this matrix equation to this given system of equations. You can change it. So this is the matrix equation. This is known as what? Matrix equation. This is known as what? This is known as matrix equation. Again, you can change this matrix equation to this given system of equation. So whether it is correct or wrong, you can check it. Okay. So let us convert this AX, capital A, matrix A, capital X. Matrix X is equal to capital C is the constant matrix. Okay. So now in this case, AX is equal to C is the matrix equation. This is known as what? Matrix equation. Or what is capital A here? It is A1, B1 and it is A2, B2. So let us check it whether this matrix equation is correct or wrong. Okay. So again, if you can convert this matrix equation into this given system of equations, if it is correct, then this matrix equation is also correct. Okay. So what is capital X here? Small x, small y, that is the column matrix. And which is the constant matrix here? It is minus C1 minus C2. So I think I have understood it. Okay. So now you can multiply them. You know how to multiply these two matrices. So what is the condition for the two matrices to be multiplied so that you can find out the product of these two matrices? So what is the condition so that you can find out the product of these two matrices? So for the first matrix, you have to check the number of columns, and for the second matrix, you have to check the number of rows. If they are equal, then you can find out the product of the two matrices. So how many columns are here? 2 columns. How many rows are there? 2 rows. That means they are equal. You can find out the product of these two matrices. Okay, you can multiply them. First row into first column. So what do we get? First row into first column, corresponding elements should be multiplied. So A1x plus B1y, right? Then is second row by first column only first column is here. So multiplied, corresponding elements should be multiplied. A2x plus this is your B2y, which is equal to this is minus C1 minus C2. Now these are the equality of two matrices, and from the definition of equality of matrices, you know that their corresponding elements should be equal. That means we can equate A1x plus B1y is equal to minus C1, A2x plus B2y is equal to minus C2. So that means we are getting this equation. So this is the correct matrix equation. Is that clear to all of you? So I think you have understood it, how to convert the given system of equations to matrix equation. Okay. Now again, question number 2 is there. So you can copy it. We'll do question number 2 now. So I think you have understood it. Okay, you can pause the video and you can copy it. So now for number 2, now there are 3 equations with 3 unknown quantities. There are 3 equations with 3 unknown quantities. Which are the unknown quantities out here? It is x, y, z. And these are all the coefficients of x, y, z, isn't it? That is a1, b1, c1, a2, b2, c2, a3, b3, c3 are the coefficients of x, y, and z. And here k1, k2, k3 are constant. Okay. So I am rubbing it now. Now let us convert this given system of equations with 3 unknown quantities x, y, z to matrix equation. Okay. So let here also capital A is equal to, now this is the coefficient matrix. That means from equation 1, let us assume it as number 1, it is as 2, this is as 3. Equation 1, equation 2 and equation 3. So let us write down the coefficient matrix A. So in this case, in the first row, you will write down the coefficients of x, y and z from the first equation. That is, in the first row, A1, B1, C1, right? And in the second row, what comes? That is the coefficient of x, y and z from the second equation. That means you can write A2, B2, C2. And in the third row, what will be there? That is the coefficients of x, y and z from the third equation. That is your A3, B3, C3. So is that clear to all of you? Now, which are the variables or unknown quantities x, y, z? So let let it be capital X. So what is capital X out here? That is the unknown quantities x, y, z. You should write it as a column matrix x, y, z. This is the column matrix. And let, which is the constant matrix, let capital C is equal to, I told you that always the constant term should be on the right hand side. So if it is on the left hand side, you should take it to the right hand side so that you can solve the given system of equations and you can easily convert that equation to matrix form. Okay, so let capital C means constant matrix. This is also the column matrix K1, K2, K3. Is that clear to all of you? Next, what will you do? Now you can convert this given system of equations to matrix form. So how will you convert it? It is AX is equal to C. This is known as what? This is known as matrix equation. So you can check it also whether this matrix equation is correct or wrong. So let us check it. That is AX is equal to C, or what is capital A here? That is the coefficient matrix. What is the coefficient matrix A? That is A1, B1, C1, A2, B2, C2, A3, B3, C3. Alright. Next, what is capital X? This is the column matrix X, Y, Z, which is equal to what is the constant matrix in this case, which are free from X, Y, and Z? That is K1, K2, K3. Is that clear to all of you? Now you can multiply these two matrices because the number of columns of the first matrix is equal to the number of rows of the second matrix. That means for the first matrix number of columns is 3 and for the second matrix number of rows is 3. That means they are equal. So you can multiply these two matrices. Okay? First row by first column. Right? So first row by first column, corresponding elements should be multiplied. So it is A1x plus B1y plus C1z. Okay? As there is no second column here, you don't have to multiply by first row out here. Okay? Then next step is second row by first column. Corresponding elements should be multiplied. So it is A2x plus B2y plus C2z. Right? Next, as there is no second column here, so you don't have to write here second element. So there is no second element in this matrix. Okay? Now third row by first column. Corresponding elements should be multiplied again. So it is A3x, then write down plus B3y plus it is C3z. So which is equal to what is here? This is K1, K2, K3. Is it clear to all of you? Now these two matrices are equal, and from the definition of equality of two matrices, you know that their corresponding elements should be equal. That means what can you write? A1x plus B1y plus C1z is equal to K1. Next, these second elements can be equated. A2x plus B2y plus C2z is equal to K2. Next, these third elements can be equated. That is A3x plus B3y plus C3z is equal to K3. So these are the answers. That means this is the given system of equations. So we have got this given system of equations, isn't it? You can compare it, they are same. Okay? So now, in order to solve the given system of equation by matrix inversion method, you should know how to convert the given system of equation to matrix form. So this is the method that you can change this given system of equations to matrix form. Now let us do solve. That is solving by matrix inversion method. Okay, so you can copy it. Now we are doing problem number 2. Solve by matrix inversion method the equations in each of the following. Here systems of equations are given. You have to solve this given system of equations by matrix inversion method. The method is known as matrix inversion method. So there are two equations with two unknown quantities. The two unknown quantities here are x and y, and there are two equations. So let us write it again. I told you that always you have to write down the constant which are free from x and y to the right hand side. Okay. So what is the first equation here? 3x plus 4y is equal to 1. Next, plus 3 is on the left hand side. You have to write it on the right hand side. Okay. So x plus 3y is equal to what? It is minus 3. So let us convert now. Let us convert this given system of equations to matrix form. So you know how to convert it to matrix form, isn't it? Let capital A is equal to, we have to write down the coefficients of x and y. Suppose this is equation 1 and this is equation 2. Now from equation 1, in the first row, you have to write down the coefficients of x and y. That is 3 and 4. So you should write here 3 and 4 in the first row. And in the second equation, what are the coefficients of x and y? It is 1 and 3. Coefficient of x is 1 here, 1. Coefficient of y here is 3. Is that clear? So in order to solve this equation with the help of matrix inversion method, you have to find out det A, because you have to get A inverse also. Okay? So let us find out det A. Det A means you have to convert into determinant form. Therefore, det A is equal to what? 3, 4, 1, 3. Or what is det A is equal to now? It is 3 3s are 9 minus 4, which is equal to 5. That means it is not equal to 0. So what does exist? A inverse exists. What does exist? A inverse exists. Okay? So now again let, what is capital X here now? What is capital X? What is capital X? It is small x and small y. This is the unknown matrix. And let, what is capital C? It is the constant matrix. Which is the constant matrix out here? 1 and minus 3. Is that clear to all of you? So now, this given system of equation, now you can convert it into matrix form. So what is the matrix equation form? Ax is equal to C. That means Ax is equal to C. Okay? Now you have to take that A to the right hand side. So when you take A to the right hand side, you cannot write it on the denominator. It becomes A inverse on the right hand side automatically. Or you can multiply it by A inverse, or as a latest, I am giving you some example out here. If you multiply both the sides by A inverse A into X is equal to A inverse C, right? So we are multiplying both the sides by A inverse. Because in this case you have to use matrix inversion method. So we are multiplying both the sides by A inverse. Okay? What is A inverse A? That is Ix is equal to A inverse C. Or what is X? What is I into X? It is just like multiplying with 1. So X into I is always X. You know from properties of matrices. X is equal to A inverse C. That means when you take this A to the right hand side, it becomes A inverse. Is that clear now? So, or you can write X is equal to A inverse C directly. But you cannot write A in the denominator. So you have to write A inverse on the right hand side. Okay? So X is equal to A inverse C. So this is your matrix equation. Now what is to be determined? You have to determine A inverse now from here. You know how to get A inverse, isn't it? What is capital A here? So capital A is equal to, what is capital A? It is 3, 4, 1, 3. Let us write it again. It is 3, 4, 1, 3. So now, in order to get the inverse of the matrix A, you should know the cofactors of each element of the matrix A. That means you have to find out the cofactor of this 3, cofactor of 4. That means cofactor of 4 and cofactor of 1 and cofactor of 3. You know how to get it, isn't it? So let us write it as A11. What is A11 actually? What is this A11? That is, A11 means cofactor of the element which belongs to the first row and the first column. You know that. Cofactor of the element which belongs to the first row and first column. First row and first column. That means 3. You should know the cofactor of 3. So in order to know the cofactor, you should consider the sign. So how can you consider the sign here? You should write minus 1 whole to the power. 1 is here. Suffix 1 is there. So it is 1 plus 1. Into. Then what do you write? You have to delete the row and the column through the element 3. That means first row and first column are deleted. What remains? 3. So into 3. Which is equal to, what is minus 1 whole squared? Plus 1, you know that. So plus 1 into 3 is always 3. And usually we don't write plus sign. Similarly, how can you get A12? How can you get A12? Minus 1 whole to the power 1 plus 2 into, now A12 means this number 4. You have to delete the row and the column through the element 4. First row and second column are deleted. What remains? 1. So it is 1, which is equal to minus 1. You know that minus 1 whole cube is minus 1. Minus 1 into 1 is minus 1. Okay. Next, what is A13? Next, A21. That means cofactor of the element belonging to the first row and the, cofactor of the element belonging to the second row and first column. Second row and first column. That means 1. You have to find out the cofactor of 1. Let us write down the sign first. Minus 1 whole to the power 2 plus 1 into, now delete the row and the column through the element 1. That means first column and second row are deleted. What remains? It is 4. So 4, which is equal to minus 4. Is that understood now? So next, what do we write? A22. What do we mean by A22? Cofactor of the element belonging to the second row and second column. Element belonging to the second row and the second column is 3. You have to find out the cofactor of 3. Let us consider the sign here also. So it is minus 1 whole to the power. This suffix is 2. You should write here 2 plus 2. Then delete the row and the column through the element 3. Second row and second column are deleted. What remains? 3. So what is this product now? So minus 1 whole to the power 4 is always plus 1. So plus 1 into 3 is always 3. So these are the cofactors. So I think you have understood it. Okay. So now let capital B be the matrix. Let capital B be the matrix whose elements are the cofactors, of the elements of matrix A, of matrix capital A. Okay. So now, what is capital B out here? You should write it as cofactors A11, A12. Then comes A21, A22. Right? This is the matrix. B matrix. So capital B is equal to what is capital B now? What is A11? It is 3. What is A12? It is minus 1. What is A21? It is minus 4. And what is A22? It is 3. This is the matrix B. So I think you have understood it. Okay. Next. Now we have to write down the adjoint of A. So what is the meaning of adjoint of A? It is the B transpose. You know that. What is B transpose here? You have to change rows into columns and columns into rows in matrix B. That means first row now becomes 3 minus 4. This first column becomes first row 3 minus 4. And this second column becomes second row minus 1, 3. This is the adjoint of A. Okay. So now what is date A here? It is 5. What is date A here? It is 5. Right. Here det A is 5 here. Now how can you get A inverse? How can you get A inverse? So A inverse is equal to 1 upon det A into ADJ. Since det A not equal to 0, so A inverse exists. So A inverse is equal to 1 upon 5 into what is adjoint of A? What is adjoint of A? It is 3 minus 4 minus 1, 3. Minus 1, 3, right? So this is your A inverse. So in order to solve the given system of equations with the help of matrix inversion method, you should find out always the inverse of the coefficient matrix A. That is, we have got A inverse. Okay? So now you know matrix equation, that is X is equal to A inverse C. Let us write it again. Okay? So capital X is equal to A inverse C. Or what is capital X now? What is A inverse? Just now we got it. A inverse. What is A inverse? 1 upon 5. 1 upon 5. Next. What are the elements here? 3 minus 4. Don't multiply it by 1 by 5. Okay? So 1 by 5 is written outside matrix. So 3 minus 4 and minus 1, 3. Minus 1, 3. And what was the constant matrix out here? So here the constant matrix was 1 and minus 3, isn't it? 1 and minus 3 was there. This is 1 and minus 3. That is your constant matrix. Now you can multiply these two matrices. 2 columns, 2 rows, they are equal. That means you can multiply these two matrices. Or capital X is equal to 1 upon 5. Now multiply these two matrices. First row by first column. 3 ones are 3, minus 2 minus plus, 4 threes are 12, right? Next, second row by first column, minus 1 into 1, minus 1, 3 into minus 3, minus 9, okay? Or capital X is equal to 1 upon 5. Now matrix is 3 plus 12 is 15 and minus 1 minus 9 is minus 10. Is that clear? Now what is capital X here? Actually capital X is the unknown matrix. That was the column matrix XY. So which is equal to, now this is the scalar multiplication of the matrix, that is 1 by 5. 1 by 5 is the scalar multiplication of this matrix. You can multiply all the elements of the matrix by that scalar multiplication. So what do we get? 5 threes are 15. You can divide 15 by 5, or 1 by 5 into 15 is 3. 1 by 5 into minus 10 is minus 2. Is that clear? So now, these are the equality of the two matrices. You know from the definition of equality of matrices, the corresponding elements can be equated. That means you can equate x with 3. That is x is equal to 3 and y is equal to minus 2. This is the final answer. So x is equal to 3 and y is equal to minus 2. So these are the solutions of the given system of equations. So this method is known as matrix inversion method. So I think you have understood it. You can pause the video and you can copy it. Okay. So we'll do the next problem now. Now, we'll do the next question, that is number 2. You have to solve this given system of equations with the help of matrix inversion method. But instead of variables x and y, it is given as x1, x2. That is the only difference here. Sometimes it may be given as a and b instead of x and y respectively. Okay. So let us write this equation again. But I told you that always you have to write down the constant terms which are free from x1 and x2 to the right hand side. Okay. Or let us write down this x1 first. That is minus x1 plus 2x2 is equal to 2. So this is equation 1. Next one is 3x1 minus 4x2 is equal to 5 is taken to the right hand side, becomes minus 5. That is equation 2. You have to keep in mind that instead of x, x1 is there. Instead of y, x2 is there. Okay. Now, what we will do here is, you have to convert this given system of equations to matrix form. Now, you know how to convert it, isn't it? So, let us assume, let the matrix A is equal to, that is the coefficient matrix, that is the coefficient of x1 and x2 from the first equation. It is minus 1, 2, from equation 2 it is 3 and minus 4. Is that clear? So, next one is, what is capital X out here? Unknown matrix or unknown variable is x1, x2. And let, what is capital C? Capital C is the constant matrix 2 and minus 5. So I think you have understood it. So in this case also, the matrix equation will be AX is equal to C. And you have to take that A to the right hand side in order to get the values of the variables x1 and x2. That means A becomes A inverse on the right hand side. That means you have to find out A inverse. So in order to get A inverse, you should know the value of date A. If date A is equal to 0, then A inverse does not exist. You can find the values of x1 and x2 in this case. So date A should not be equal to 0. So let us find out date A. So date A is equal to, let us convert it into determinant form, minus 1, 2, 3, minus 4, right? Minus 1, 2, 3, minus 4. So we can expand it. So what is date A is equal to now? Minus to minus plus 4 minus 3 to 6, which is equal to minus 2. It is not equal to 0. So that means A inverse exists. What does exist? A inverse exists. Right? So now you can convert this given system of equation to a matrix form. So how can you convert it into matrix form now? Matrix form is what? Therefore, AX is equal to capital C. Now take A to the right hand side. So what does it become? Capital X is equal to A inverse C. Okay? Now you have to find out A inverse. So, अब हामीले यो A inverse निकाल्नै पर्छ. A inverse निकालिसकेपछि मात्रै हामीले यसलाई पुरा solve गर्न सक्छौं. So let us find out A inverse now. So in order to get the values of x1 and x2, first of all you have to get the inverse of the matrix A. That means you have to find out A inverse. Okay? So you know how to find out A inverse, isn't it? So you have to write down the cofactors of each element of the matrix A. Okay? Let us write down the matrix A again. A is equal to, what is here? What is matrix A? Let us write it. Minus 1, 2. It is minus 1, 2. Next, 3 minus 4. 3 and minus 4. Okay? So now, in this case, you have to write down the cofactors of each element of the matrix A. That is, it is denoted by A11. What is meant by A11? I already told you that A11 means you have to find out the cofactor of the element belonging to the first row and first column. A, this 1 means first number denotes row, second number denotes column. That means A11 means you have to find out the cofactor of the element belonging to the first row and the first column. First row and the first column. That is minus 1. So minus 1, A11. Small A11 is actually minus 1 out there. So you have to find out the cofactor of minus 1. So in order to know the cofactor, you should consider the sign. How can you consider the sign here? Always minus 1 whole to the power. 1 is there. Suffix is 1. You should write 1 plus 1. Now, you have to delete the row and the column through the element minus 1. That means first row and first column are deleted. What remains? Minus 4. So into minus 4, which is equal to, what is the value now? Minus 1 whole square is always plus. Plus and minus is minus 4. Minus 4, right? Similarly, how can you get A12? Now you know the meaning of A12. So always write down the sign first. Minus 1 over the power 1 plus 2 into, delete the row and the column through the element 2. A12 means you have to find out the cofactor of the element belonging to the first row and the second column. first row and the second row. That means 2. What is the cofactor of 2? Delete the row and the column through the element 2. First row and second column are deleted. What remains? 3 into 3. So which is equal to, simplify it, what do we get? Minus 1 whole cube is minus 1. Is minus 1 into 3 is equal to, what is here? It is minus 3. Okay. Next, this is the element in the second row and the first column, isn't it? Second row and the first column. That is A21. That is cofactor of the element belonging to the second row and the first column. Second row and the first column. That means 3. You have to find out the cofactor of 3. So first of all, consider the sign. Minus 1 whole to the power 2 plus 1 into, delete the row and the column through the element 3. Second row and first column are deleted. It remains only 2. So if we simplify it, what do we get? Minus 2. Right? Then comes what? A22. That is cofactor of the element belonging to the second row and second column. Second row and second column. That is minus 4. Cofactor minus 4. What is cofactor of minus 4? First of all, consider the sign. Minus 1 whole to the power 2 plus 2. Now delete the row and the column through the element minus 4. Second row and second column are deleted. What remains? Minus 1. So what is this value? Minus 1 whole to the power 4 is plus 1. Plus to the minus is minus 1. Is that clear? So we have determined the cofactors of each element of the matrix A. Now let capital B be the matrix. Let capital B be the matrix whose elements are the cofactors. Let capital B be the matrix whose elements are the cofactors of matrix A. Of matrix capital A. Is that clear now? What's the next? What is capital B here? It is A11, A12, A21, A22. This is the matrix B, whose elements are the cofactors of the elements of matrix A. Or what is capital B out here? What is capital B? What is A11? It is minus 4. What is A12? Minus 3. What is A21? Minus 2. What is A22? This is minus 1. All are minus sign here. Okay? What's the next? So here data is minus 2, right? So let us write down adjoint of A. What is ADJ? A is equal to, it is defined as B transpose, you know that. So ADJ A is equal to, what is B transpose? That is, you have to change rows into columns and columns into rows in matrix B. That is, minus 4, minus 2 becomes the first row and minus 3, minus 1 becomes the second row. Is that clear? So let us find out A inverse now. So here A inverse exists, you know that. So A inverse is equal to 1 upon data into ADJ A. Therefore, A inverse is equal to minus half. That is 1 upon minus 2 will be there. Data is minus 2 here. And what is adjoint of A? This is the matrix. Minus 4, minus 2, minus 3, minus 1. So this is the inverse of the matrix A. Is it clear now? So next, let us write down the matrix equation. So we know that what is the matrix equation? X is equal to A inverse C. C is the constant matrix, right? X is the unknown matrix. Capital X is equal to, what is A inverse? Let us write it. It is minus half, then minus 4, minus 4, minus 2, minus 3, minus 1. Minus 3, minus 1. Right? And so what was the constant matrix here? The constant matrix here are 2 and minus 5. 2 and this is your minus 5. So these are the constant. This is the constant matrix 2 and minus 5. So you can multiply these two matrices because number of rows here is 2 and number of columns Number of columns in the first matrix is 2 and number of rows in the second matrix is also 2. They are equal. That means you can multiply them. Or capital X is equal to minus half. Now you can multiply these two matrices. First row by first column, minus 4 into 2, minus 8. Minus and minus plus 5 2s are 10. Right? Next, second row by first column, minus 3 into 2, minus 6, minus and minus plus 5. Is that clear? And next one is capital X is equal to minus half, and this is 10 minus 8 is 2, minus 6 plus 5 is minus 1. Or you can write capital X, your unknown quantities are x1, x2, isn't it? You have to get the values of x1 and x2, which is equal to, now multiply by minus half here. This minus half is the scalar multiplication of that matrix. So you have to multiply each element of the matrix by minus half. So what do we get? Minus half into 2, minus 1, minus half into minus 1, this is half. So these are the equality of the two matrices. You can equate the corresponding elements. So x1 is equal to minus 1, and what is x2 here? x2 is equal to, this is half. So this is your answer. That means, what are the values of the unknown quantities? x1 is equal to minus 1 and x2 is equal to 1 upon 2. So this is how to solve given system of equations with the help of matrix inversion method. Is that clear? So you can pause the video and you can copy it. We'll do the next question now. Now we'll do question number 6. That is also solve by matrix inversion method the following systems of equations. So systems of equations are given here. You have to solve it with the help of matrix inversion method. So question number 4 is 8x plus 4y plus 3z is equal to 18. 2x plus y plus z is equal to 5. X plus 2y plus z is equal to 5 also. So I already told you that when the constant term is on the left hand side, you take that constant term to the right hand side always. So in this case, in this equation, all the constant term are on the right hand side. Okay? So यो question मा हामीलाई यो जुन चाहिँ constant term छ सबै right side मै दिएको छ. त हामीले right side मा लगिरहनु पर्दैन, already they are on the right hand side. So these are the three equations with three unknown quantities. So in the previous problem, we solved the given system of equations in which there are two unknown quantities with two equations. That is, x and y were given and only two equations were given out there. So in this case, three equations are given with three unknown quantities, that is x, y and z. Okay, let us write it again. Given is 8x plus 4y plus 3z is equal to 18. This is equation number 1. 2x plus y plus z is equal to 5. That is equation number 2. Next, x plus 2y plus z is equal to 5. That is equation number 3. So now what will you do in the next step? Let us write down the coefficient matrix. Let capital A is equal to, which is the coefficient matrix here? You have to write down the coefficient of x, y and z from the first equation here in the first row. That is 8, 4, 3. 8, 4, 3. Next, equation 2, what are the coefficient of x, y and z? We will write it in the second row, 2, 1, 1. In equation 3, what are the coefficient of x, y and z? 1, 2, 1. This is the matrix A. Next, capital X, which are the unknown quantities? This is the unknown matrix x, y, z. You should write it as a column matrix x, y, z. And which is the constant matrix C? What is C is equal to 18. This is 5 and this is 5. Is that clear to all of you? So you can convert these given systems of equations to matrix form. So what is the matrix form here? it is, as you know, that AX is equal to C, or X is equal to A is taken to the right hand side becomes A inverse C. That means what is to be determined here? You have to determine A inverse. So in order to get A inverse, you should find out the value for det A. If det A not equal to 0, then only A inverse exists. Otherwise, A inverse does not exist. So I think I've understood it. Okay, let us find out det A. So what is det A out here? What is det A here? So you can convert this given matrix, that is Kurseong matrix A, in terms of determinant form. So it is 8, 4, 3, first row. First row is 8, 4, 3. What is the second row? 2, 1, 1. 2, 1, 1. Third row? 1, 2, 1. So you know how to expand it, isn't it? This is the third order matrix, is third order determinant. This is the third order determinant. You know how to expand it. Let us expand it with respect to the first row. 8, 4, 3. If you take 8 plus minus plus, so 8. So if you take 8, delete the row and the column through the element 8. What remains? 1, 1, 2, 1. 1 ones are 1, minus 2. Then next, minus 4 within bracket. Delete the row and the column through the element 4. First row and second column are deleted. 2, 1, 1, 1. That means 2 ones are 2, minus 1. 2 ones are 2, minus 1, right? Then comes plus 3. Plus 3 within bracket. Delete the row and the column through the element 3. 2, 1, 1, 2 remains. So 2 2s are 4, and then it is minus 1. Is that clear? Now let us simplify it. 8 minus 1 minus 4 into 1 plus 3 into 3, right? So 8 into minus 1 minus 4 into, this is 2 minus 1 is 1. 3 into 4 minus 1 is 3. So it is minus 8 minus 4 plus 9, which is equal to minus 12 plus 9, which is equal to minus 3, which is not equal to 0. That means A inverse exists. That means A inverse exists. And so now you have to write down the cofactors of each element of the matrix A. Now in this case, you have to write down the cofactors of each element of the matrix A in order to get this A inverse, because you should know the adjoint of the matrix A. Okay, so let's find it. So now first of all, let us find out A11. You know what is A11? Elements belonging to the first row and first column. This A11 means, and this first one becomes the, this first one indicates first row, second one indicates first column. A11 means cofactor of the element belonging to the first row and the first column. That means 8, isn't it? What is the cofactor of 8? First of all, consider the sign minus 1, whole to the power 1 plus 1. Now delete the row and the column through the element 8. You have to write it in the determinant form. Delete the row and the column through the element 8. First row and first column are deleted. What remains? 1, 1, 2, 1. Let us write here 1, 1, 2, 1. It is 1, 1, 2, 1. Right? So what is minus 1 whole square? It is plus 1. Usually we don't write plus 1, right? So let us expand it. It is 1. It is 1 minus 2. Which is equal to, what is here? Minus 1. This is your A11. Next, this fourth means A12, that is cofactor of the element belonging to the first row and second column. First row and second column. That means 4. You have to find out the cofactor of what? 4. Right? So how can you get it? Let us consider the sign minus 1 whole to the power 1 plus 2. Now delete the row and the column through the element 4. First row and second column are deleted. What remains? 2, 1, 1, 1. 2, 1, 2, 1, 1, 1. Is that correct? 2, 1, 1, right. So what is minus 1 whole to the power cube? What is minus 1 whole to the power 3? It is minus 1 within bracket 2 ones are 2. It is 2 ones are 2, then minus 1. Which is equal to minus 1. This is your A12. Right? So we have got here data is equal to what? Let us write it. Det A is equal to minus 3. Det A is equal to minus 3. So now let us find out A13. That is cofactor of the element belonging to the first row and third column. First row and third column. That means 3. You have to find out the cofactor of that last 3 in the first row. Right? 3. So what is the cofactor of 3? First you consider the sign minus 1 over the power 1 plus 3. Now delete the row and the column to the element 3. That means 2, 1, 1, 2 remains. So it is 2, 1, 1, 2. Which is equal to, what is minus 1 over the power 4 plus 1? Usually we don't write plus 1. So 2 2s are, it is 4 minus 1, which is equal to 3. Understood? So next one is, you can find out A21. What is A21? Cofactor of the element belonging to the second row and first column. Second row and first column. That means 2. So minus 1 over the power 2 plus 1. Right? 2 plus 1. That is minus 1 over the power 2 plus 1. Now delete the row and the column to the element 2. That means second row and first column are deleted. 4, 3, 2, 1 remains. 4, 3, 2, 1. Right? 4, 3, 2, 1. Which is equal to, this is 4 1s are 4. This is minus 6, which is equal to minus 2. Right? So next one is A22. What is A22? Minus 1 over the power 2 plus 2. That means A22 means this element, you know that. Now you know A22, right? That is cofactor of the element belonging to the second row and second column. That means you have to find out the cofactor of this one. So minus 1 over the power 2 plus 2 is there, right? Then delete the row and the column to the element 1. Second row and second column are deleted. 8, 3, 1, 1. 8, 3, 1, 1. Which is equal to minus 1 over the power 4 is, oh sorry, this is, I have done a mistake out here. Sorry. This one is minus 1 over cube, isn't it? What is minus 1 over cube? This is minus 1 and within bracket 4 1s are 4 and this is minus 6. Minus 1 over cube is minus 1. 4 1s are 4 minus 6. Which is equal to, if you simplify, what do we get? It is 2, right? So what is minus 1 over the power 4? It is minus 1 over the power 4 is plus 1. Usually we don't write 8. 8 1s are 8. 8 1s are 8 minus 3 1s are 3, which is equal to what? It is 5, right? So next one is A23. What is A23? Cofactor of the element belonging to the second row and third column. Second row and third column. That means 1. You have to find out the cofactor of that one. Cofactor of this one. Not this one, not this one, and not this one. But cofactor of this one, which belongs to the second row and third column. Second row and third column. So minus 1 whole to the power 2 plus 3. So it is minus 1 whole to the power 2 plus 3. Right? So it is minus 1 over the power 2 plus 3, okay? Then what? Delete the row and the column through the element, this one. Second row and third column are deleted. 8, 4, 1, 2. 8, 4, 1, 2. So which is equal to, what is minus 1 over the power 5? Minus 1, 8 2s are 16. 8 2s are 16, then minus 4. Which is equal to minus 12. Is that clear to all of you? So we have found out the 6 cofactors. So let us write it here because we have to rub it. Okay. So A11 कति आयो? A11 minus 1 छ हैन? A12 पनि कति छ? A12 पनि कति छ? Minus 1 नै छ. A12 पनि कति छ? Minus 1. A12 is also minus 1. A13 3. A13 is 3, right? A13 is 3, A21 is 2, A21 is 2, right? A21 is 2 and A22 is 5, A22 is 5, and what is A23? A23 is minus 12, okay? So let us check it once again here. What is A11? Minus 1. A12 minus 1, A13 3, A21 it is 2, A22 5, A23 that is minus 12. तो मैले चाहिँ यहाँ किन लेखेँ भन्दा अहिले यो रब गर्नुपर्छ नि त हैन I have to rob it, then only I can write it here. So that's why I have written here. No need of writing in your copy, this one. Okay, this one you don't have to write it in your copy. Okay. So now, so actually this is the matrix A, right? Now we have to find out what A23 is. We have determined A23. Now we have to find out A31. So now can you tell me what is A31? What is A31? That is cofactor of the element belonging to the third row and first column. Third row and first column. That means 1. You have to find out the cofactor of this one. That is third row and first column. So you have to consider the sign -1 all to the power 3 plus 1. And now delete the row and the column through that element 1. What remains? 4, 3, 1, 1. 4, 3, 1, 1. Which is equal to, now it is -1 all to the power 4 is plus 1. Usually we don't write. 4 ones are 4. Minus 3, which is equal to 1. Next, capital A32. What is capital A32? Cofactor of the element belonging to the third row and second column. Third row and second column. That means 2. Cofactor of 2. So it is -1 all to the power 3 plus 2. Now delete the row and the column through the element 2. That is third row and second column are deleted. 8, 3, 2, 1. 8, 3, 2, 1. Which is equal to, it is minus sign, -1 all to the power 5. You know that it is minus. So it is 8 ones are 8 minus 6. 8 ones are 8 minus 6, which is equal to -2. Is that understood now? So in the last step, what is to be found out? So you have to find out A33. That is, you find out A33. So what is A33 actually? Cofactor of the element belonging to the third row and third column. Third row and third column. That means this one. Okay. Now -1 all to the power 3 plus 3. First of all, you have to consider the sign. -1 all to the power 3 plus 3. Now delete the row and the column through this element 1. That means third row and third column are deleted. What remains? 8, 4, 2, 1. Right? So it is 8, 4, 2, 1. Which is equal to, what is -1 all to the power 6? -1 is multiplied 6 times. That is even number of times. So it is plus 1. So usually we don't write plus 1. So it is 8 ones are 8 minus 8, which is equal to 0. So I think you have understood it. That is A33 is 0. Right? So now, so what will you write in the next step? You have to write down the matrix B, whose elements are the cofactors of the elements of matrix A. So let us write it. Let capital B be the matrix. Let capital B be the matrix whose elements are the cofactors of the elements. Let capital B be the matrix whose elements are the cofactors of the elements of matrix A. Of matrix capital A. Okay. So how can you write capital B now? This is A11, A12, A13. Next comes A21, A22, A23. Next comes A31, A32, A33. So this is the cofactors. Matrix B. Or what is capital B here? What is this A11? A11 is -1. What is A12? This is also -1. What is A13? A13 is 3. Right? What is A21? It is only 2 is there. A22, that is 5. And A23, that is -12. Isn't it? A23 is -12, right? So what is A31? Just now we found out. What is A31? It is 1. What is A32? -2. What is A33? That is your 0. So this is the cofactors of the elements of the matrix A. That is, it is denoted by matrix B. Now you have to get adjoint of A. So therefore, ADJ capital A is equal to B transpose, or ADJ A is equal. Now in this case also you have to change columns into rows and rows into columns. Now this is the first column becomes the first row out here. -1 2 1 -1 2 1, then -1 5 -2. This same column becomes the second row. Then 3 -12 0. That means this third column becomes the third row here. That is your adjoint of A. Now we have to find out A inverse. Let us find out A inverse now. Now let us find out A inverse. So what is the formula for A inverse? You know that. What is A inverse actually? It is 1 upon det A into ADJ A. 1 upon det A into ADJ A. Okay? So, or A inverse is equal to 1 upon det A. What is det A? Actually, det A was -3. That is -1 upon 3. Now write down ADJ A. What is ADJ A? -1 2 1. -1 2 1. Then -1 5 -2. -1 5 -2. Then comes 3 -12 0. 3 -12 0. So this is your A inverse. Okay. Now you know how to get the inverse of the matrix A. So using this inversion matrix, you have to solve the three given system of equations, right? So there was a matrix equation in the beginning steps. In the beginning of these steps, there was a matrix equation. What was that matrix equation? That is capital X is equal to A inverse C. So capital X is equal to, what is the inverse? Write down inverse. -1/3. Then what is the matrix here? -1 2 1, -1 5 -2, 3 -12 0. Right? Is that correct? -1 2 1, -1 5 -2, 3 -12 0. And now we have to write down the column matrix C. What is the column matrix C out there? Column matrix C is 18 5 5. The column matrix was, or constant matrix was 18 5 5. So now you have to solve it. You have to get the values of individual values of X, Y and Z. Okay. Now can you multiply these two matrices? For the first matrix you have to check, you have to consider the number of columns, that is number of columns is 3. And for the second matrix you have to check the number of rows, that is number of rows is also 3 out there. So that means that equal number of columns is your number of rows, you can multiply the two matrices. Therefore capital X is equal to -1/3. Now first row by first column. Corresponding elements should be multiplied. -1 into 18, -18, 2 5s are plus 10, 1 into 5 plus 5, plus 5, right? -1 into 18, -18, 2 5s are plus 10, 1 into 5 plus 5. Now second row by second column, what do we get? This -1 into 18, -18, 5 5s are 25, 5 5s are 25, -10, right? This is your -10. Is that clear? Again, third row by first column. Third row by first column. 18 3s are, that is your 54, -60, isn't it? -12 into 5, -60, plus 0 into 5, that is 0. So I think you have understood it. Okay. So or capital X is equal to -1/3 within third bracket or within matrix sign. 10 plus 5 is 15. -18 plus 15, 25. This is your -28. Right? -18 -10. Same sign, add them. And it is 54 -60 is -6. Or capital X is equal to -1/3. So what is here? This is -3, right? 25 minus 28. That is also -3, right? and minus 6. And the last one is now, this is the unknown matrix capital X, that is x, y, z, which is equal to, now we can multiply all these elements by this scalar multiplication of the matrix, that is minus 1/3. So minus into minus plus. So 1/3 into 3 is 1. Again minus into minus plus, 1/3 into 3 in 1. Minus into minus plus, 3 2s are 6. So this is the equality of the two matrices. So you can equate the corresponding elements here. That means x is equal to 1, y is equal to 1, z is equal to 2. So these are the answers. So I think you have understood it. So you can copy it, you can pause the video and you can copy it. Now we'll do the next question now. So now we will do this question. That means you have to solve this equation. But this equation is given in terms of fraction. That is, all the variables are in the denominator. But here the variables are given as a, b and c, but these are in the denominator. So what is the first equation here? 1 upon a plus 2 upon b plus 3 upon c is equal to 14. What is the second equation? 5 upon a minus 2 upon b minus 1 upon c plus 2 is equal to 0. And in the third equation, it is given 3 upon a minus 4 upon c plus 9 is equal to 0. So, in the third equation, what is missing there? B is missing there. Okay? The unknown quantity B is missing out there. And also I told you that you have to take that constant term which are free from A, B and C to the right hand side. So let us write it again. Therefore, 1 upon A plus 2 upon B plus 3 upon C is equal to 14. Next, 5 upon A minus 2 upon B minus 1 upon C. Minus 1 upon C is equal to minus 2. Now plus 2 is taken to the right hand side. It is minus 2. Then next one is 3 upon A, right? Then write down plus 0 upon B. You can write it. Plus 0 upon B. Okay? Because there is no term containing the variable B. So that's why we write it as plus 0 upon B. Then plus 0 upon B plus minus 4 upon C, and take that 9 to the right hand side, that is, it is minus 9. Is that clear? So plus 9 constant is taken to the right hand side, so it becomes minus 9. So this is equation. So let us assume, let 1 upon A is equal to X, 1 upon B is equal to Y, 1 upon C is equal to Z. So in order to solve this equation, let us assume 1 upon A is equal to X, 1 upon B is equal to Y, 1 upon C is equal to Z. So this equation now becomes, what is 1 upon A here? It is X. Plus 2 into what is 1 upon B? It is Y. Plus 3Z, which is equal to 14. Is that clear? Next, this second equation now becomes 5x minus 2y, 1 by b is y, and minus z. Minus z is equal to minus 2. Next one is, what is here? That is 3 by a means 3x. 3x plus 0 into what is 1 by b? It is y. And then minus 4 into what is 1 by c? Z, which is equal to minus 9. This is equation 1, this is equation 2, and this is equation 3. Now you can use the same method that we have done in the previous problem. Okay? So we have to write down the coefficient matrix A, that is capital A is equal to, what is capital A out here? This is the coefficient matrix, that means you have to write down the coefficient of x, y and z as the matrix form. So in equation 1, what are the coefficient of x, y, z? 1, 2, 3, 1, 2, 3, What is the coefficient of XYZ in equation 2? It is 5 minus 2, 5 minus 2 minus 1. And what are the coefficient of XY and Z in the third equation? That is 3, 0 minus 4. 3, this is 3, 0 minus 4. 3, 0 minus 4. This is the matrix A. And next one is, what is capital X unknown matrix out here? What is capital X out here? It is X, Y, Z. This is your X, Y, Z. This is the unknown matrix X, Y, Z. And what is the column or what is the constant matrix in this case? That is C is equal to, right? C is equal to, what is C is equal to here? 14 minus 2 minus 9. It is 14 minus 2 minus 9. This is your 14 minus 2 minus 9. So I think I understood it. So now we can convert these given systems of equations to matrix form. So what is the matrix equation out here? AX is equal to C. This is your matrix equation. So what is the value for the matrix capital X is equal to A is taken to the right hand side becomes A inverse C. Now we have to find out A inverse. So in order to get A inverse, you should know det A. You have to expand this determinant of A so that det A should not be equal to 0 in order to get A inverse. Okay. Now what is det A now here? So det A is equal to, let us convert into determinant form. 1, 2, 3, then 5 minus 2 minus 1, then 3, 0 minus 4. So this is the determinant. 1, 2, 3, 5 minus 2 minus 1, 3, 0 minus 4. So let us expand it. What is det A is equal to? You can expand it with respect to the first row, 1, 2, 3, plus minus plus, you know that, isn't it? So let us take 1, plus 1. Now delete the row and the column to the element 1. So what remains? Minus 2, minus 1, 0, minus 4. You can cross multiply it. Minus 2 minus plus 8, minus 0, right? Then comes minus 2. So within bracket, delete the row and the column to the element 2. First row and second column are deleted. 5 minus 1, 3 minus 4. 5 into minus 4, minus 20, minus 2 minus plus 3. Is that clear? Next, plus 3. Plus 3 within bracket, you will take this 3, delete the row and the column through that element. 3, first row and third column are deleted. What remains? 5, 0, minus 2, 3. So 5 zeros are 0, minus 2 minus plus 3 2s are 6. So let us simplify it now. So let us simplify it. Therefore, det A. So det A is equal to 1 into 8. That is your 8. Minus 2 within bracket. Minus 20 plus 3. Minus 17. Then plus 3 into 6. 3 6 are 18, right? Plus into plus is plus. 3 6 are 18. So which is equal to 8 minus 2 minus plus. 17 2s are 34 plus 18, which is equal to, how much is it now? 20, 8 plus 4, 12 plus 8, 22. 2 remains, 3 plus 2, 5 plus 1 is 6. That is 60, which is not equal to 0. So you can write here. So what can you write here? A inverse exists. Now let us find out A inverse. Okay? You have to find out the inverse of the matrix E. So how can you get the inverse of the matrix A? So you should know the cofactors of each element of the matrix A. So you know how to get it, isn't it? So we have done A inverse, how to get A inverse, isn't it? So let us write A11. That means cofactor of the element belonging to the first row and the first column. That means this one. So let us consider the sign minus 1 over to the power 1 plus 1. And now delete the row and the column to the element 1. That means minus 2 minus 1, minus 2 minus 1, 0 minus 4, which is equal to minus 1 whole square is plus. Usually we don't write it. Now cross multiply, what do we get? Minus 2 minus plus 8, then plus 0, which is equal to 8. Right? Next, A12. Consider the sign minus 1 over the power 1 plus 2. Now we have to read the row and the column to the remaining 2. What remains? 5 minus 1. It is 5 minus 1, then 3 minus 4. 3 minus 4, which is equal to minus 20 plus 3, which is equal to minus 17. Right? Then comes what? A13, which is equal to minus 1 over the power 1 plus 3. Now delete the row and the column through the element. Which element? First row and third column. First row and third column. That means first row and third column are deleted. 5 minus 2, 3, 0. 5 minus 2, 3, 0, which is equal to oh, I've done mistake out here. So what is minus 1 whole cube? You have to consider the sign. Minus 1 whole cube is minus 1. And within bracket minus 20, this is minus 20 plus 3, which is equal to plus 17, right? Now what is minus 1 over the power 4? It is plus. Usually you don't write it plus 1. 5 zeros are 0 plus 6, which is equal to what is here? This is 6. Clear? So next one is A21. That means cofactor of the element belonging to the second row and first column. Second row and first one. That is 5. Consider the sign minus 1 over the power 2 plus 1. Now delete the row and the column through the element 5. Second row and first column are deleted. 2, 3, 0 minus 4. 2, 3, 0 minus 4. It is 2, 3, 0 minus 4, isn't it? Cofactor of this 5, isn't it? So 2, 3, 0 minus 4. 2, 3, 0 minus 4. Which is equal to what is minus 1 whole cube? Minus 1, and within bracket minus 8 minus 0, which is equal to how much is it? Minus 8 into minus 1, that is plus 8. Right? Then comes A22. What is A22? Minus 1 over the power 2 plus 2. You have to find out the cofactor of the element belonging to the second row and the second column. Second row and second column. That is minus 2. Delete the row and the column to the element minus 2. 1, 3, 3, 4. 1, 3, 3 minus 4. It is 1, 3, 3 minus 4. So minus 4 to the power 4 is plus 1. Usually we don't write it. So which is equal to minus 4 minus 9 is equal to minus 13. So I think you have understood it. Okay. So date A was 60, right? Let us write it here because I may drop this one. Okay. So we don't have to copy it. So date A is equal to 60. What is A11? A11 is 8. What is A12? A12 is 17. A13 is 6. A13 is 6. A21 is what? A21 is 8. And A22 is, what is A22? It is minus 13. I have written it because I may drop this one. Okay. So you can pause the video and you can see it also. So let us take data is equal to 60. A11 8, A12 17, A13 6, A21 8, and A22 is minus 13. Okay. So now from here you have to find out the cofactors again. A23. So what is A23? Cofactor of the element belonging to the second row and third column. Second row and third column, that is minus 1. Cofactor of minus 1. Okay. Consider the sign minus 1 over to the power 2 plus 3. Right. Now cofactor of the element minus 1. Delete the row and the column through the element minus 1. 1, 2, 3, 0. 1, 2, 3, 0. Which is equal to minus 1. So now it is, we are getting the value for A23, that is cofactor of the element belonging to the second row and the third column. That is minus 1 over to the power 5 is minus 1, then within bracket 0 minus 6, which is equal to plus 6. Right? Then comes A31. So we have got A23. Now let us find out A31. That means Cofactor of the element belonging to the third row and first column. Third row and first column. That is cofactor of 3. That is minus 1 whole to the power 3 plus 1. Now delete the row and the column through the element. 3. That is 2, 3. 2, 3 minus 2 minus 1, which is equal to, what is minus 1 whole to the power 4? It is plus 1. Usually we don't write it, right? And 2, 3 minus 2 minus 1 is there. You can expand this determinant. So minus 1 whole to the power 4 is plus 1. Usually we don't write it. 2 into minus 1 is minus 2, then plus 6. Minus 2 minus plus 6. 6 minus 2 is 4, right? Then comes A32 minus 1 whole to the power 3 plus 2. Let us write down the sign first. Now we have to find out the cofactor of the element belonging to the third row and second column. Third row and second column. That means 0. Cofactor of 0. What is it? What is the cofactor of 0? That is minus 1 whole to the power 3 plus 2. You know that, isn't it? So it will be minus. Now delete the row and the column to the element 0. Third row and second column are deleted. 1, 3, 5 minus 2. 1, 3, 5 minus 1. 1, 3, 5 minus 1. Okay? So what is minus 1 whole to the power 5? It is minus 1 always. And within bracket, minus 1 minus 15, which is equal to, it is 16, plus 16. Okay? Now we have to find out A33, which is equal to minus 1 whole to the power 3 plus 3. Now we have to find out the cofactor of the element belonging to the third row and third column. Third row and third column means minus 4. So we have considered the sign. Now delete the row and the column to the element minus 4. That is 1, 2, 5 minus 2. 1, 2, 5 minus 2, which is equal to, what is minus 1 whole to the power 6? What is minus 1 whole to the power 6? It is plus 1 always. Now we have to expand this determinant. It is minus 2 minus 10, which is equal to minus 12. So I think you have understood it. Okay? So you can copy it. So we have calculated A31, A31, A32 and A33. Okay? Next. So next we will write down, let B be the matrix, let capital B be the matrix, let capital B be the matrix whose elements are the cofactors, whose elements are the cofactors of the elements of matrix A. Of matrix A, right? So therefore capital B is equal to, what is capital B here? A11, A12, A13, A21, A22, A23, then this is A31, A32, A33. So let us put the value. What was A11? A11 is 8. What is A12? It is 17, right? And A13 is 6. A13 is 6. A21 is 8. A21 is 8. A22 is minus 13, right? And what is A23? It was 6. It was 6. And what is A31? What is the value for A31? A31 is 4. A31 is 4. And what is A32? It is 16. And what is A33? It is minus 12. So this is your matrix B. Now we have to find out the adjoint of A. What is adjoint of A? B transpose, you know that. ADJ is equal to B transpose. That is ADJ A is equal to, we have to change rows into columns and columns into rows. First column becomes the first row, 884. Second column becomes the second row, 17 minus 13, 16. And this third column becomes the third row, that is 6, 6 minus 12. This is 6, 6 minus 12. Is that clear? So this is adjoint A. Now we have to find out A inverse. So let us find out A inverse now. So let us find out A inverse now. What is A inverse here? What is the formula for A inverse? A inverse is equal to 1 upon date A into what? A is A. 1 upon date A into A is A. So here A inverse is equal to 1 upon 60. Date A is 60. And what is the adjoint of A? Let us copy it. 8 and 4. 8 and 4 next. 17 minus 13. Then 16. 17 minus 13. Then 16. 6, 6 minus 12. 6, 6. Then last one is minus 12. Is that clear to all of you? So this is your A inverse. Is that clear to all of you? So you can copy it. Now, in order to get the values of the unknown quantities, let us write down the matrix equation again. What is matrix equation? Capital X is equal to A inverse C. Or capital X is, what is A inverse here? We just got it, A inverse 1 by 60, then it is 884, 17 minus 13, 16, 6, 6 minus 12. And what was capital C? What was the constant matrix in this case? So it is 14, right? So it is 14, then comes next minus 2 minus 9. Minus 2 minus 9. Minus 2 minus 9. Okay? So you can multiply these two matrices. You can multiply the two matrices here now. You can multiply these two matrices. For the first matrix, you have to consider the number of columns, that is 3. And for the second matrix, you should consider the number of rows, that is 3. They are equal. That means you can multiply them. Or capital X is equal to 1 upon 60. Now multiply the two matrices. First row by first column. 8 into 14 what? 8 4s are 32. 2, 3, 11. Then minus 16. Corresponding 11 should be multiplied. Minus 16 minus 36. Minus 36. Is that clear to all of you? Okay. Next, second row by first column. 7 into 14. What is 14 into 17? You can multiply them. 7 4s are 28. 2, 9, 4, 1, 8, 238, right? So 17 into 14. 7 into 14 is 238. So this is your 238. Next, minus 13 into minus 2 plus 26 plus 26. This is plus 26, isn't it? This is minus into minus plus 26. Then 16 into minus 9 minus 144. Is that clear? Yes. Now third row by first column. 14 into 6. 84. Then minus 12. That is 6 into minus 2 minus 12. Then minus 12 into minus 9 plus 108. Plus 108. Okay. So matrix sign is closed. So you can simplify it. X is equal to 1 by 60. Now this is 112, same sign can be added, minus this is your 52, this is 6 to 264 minus 144, right? And this one is 192, 84 plus 108, 8 plus 4, 12, 1, 8 plus 1, 9, 1, then minus 12. Is that clear? So you can simplify it further. Now you can easily simplify it. Okay, now we can simplify it further. That is capital X is equal to 1 by 60. 1 by 60, then what is 112 minus 52? It is 60, right? 264 minus 144, 4 minus 4, 0, 6 minus 4, 2, 2 minus 1 is 1. Next one is 2 minus 2, 0, 9 minus 1, 8, this is 1. Or what is capital X here? X, Y, Z. Actually, this capital X is X, Y, Z is equal to. Now, this is the scalar multiplication of the matrix 1 by 60. You have to multiply all these elements of the matrix by 1 by 60. So multiply them. It is 1, 2, 3. 1, 2, 3. Okay. So now next what will you do? So this is the equality of two matrices. You can equate the corresponding elements. That means you can equate x is equal to 1. Next, y is equal to 2. Y is equal to 2. Next, z is equal to 3. But these are not the answers. Because we had assumed x is equal to 1 upon a, y is equal to 1 upon b, and z is equal to 1 upon c. So now let us convert it into a, b and c respectively. Actually x was 1 upon a is equal to 1, y is 1 upon b is equal to 2. What is z? 1 upon c is equal to 3. That means what is the value for a out here? 1. What is the value for b? It is half. And what is the value for c? It is 1 upon 3. So this is the answer. So the answer is a is equal to 1, b is equal to half, and c is equal to 1 upon 3. So I think you have understood it. Okay, you can copy it, you can pause the video and you can copy it. So now I'll give you the homework. You can do all these problems at home. Okay. So now these are your homework, right? So these are your homework. So you can do them at home. That is page number 214 from the same book, Higher Mathematics for class 12 by S&A. Page number 214, exercise 3, section each question carries 5 marks. So you have to solve all these equations by matrix inversion method. So 2 number 3 is 2a plus 5b plus 1 is equal to 0. 2a minus 5b plus 1 is equal to 0, 5a minus 7b is equal to 3, and number 4, 7x plus 4y plus 1 is equal to 0, and 3x plus y is equal to 1. And in question number 6 also, you have to solve by matrix inversion method the following systems of equations. Now in these equations, there are 3 equations with 3 unknown quantities, x, y, and z. Okay, so number 1 is 2x plus y plus z is equal to 2, x plus 3y minus z is equal to 5, 3x plus y minus 2z is equal to 6. This is number 2, this is number 3, and this is number 5, this is number 6. Now in number 6, it is 2 by x minus 3 by y plus 3 by z is equal to 10, 1 by x plus 1 by y plus 1 by z is equal to 10, 3 by x minus 1 by y plus 2 upon z is equal to 13. So in this case, you have to assume 1 by x is equal to small a, 1 by y is equal to small b, 1 by z is equal to small b. Then again you have to, using matrix inversion method, you can find out the values of a, b and c. Again you have to convert that a, b and c in terms of 1 upon x, 1 upon y, 1 upon z respectively to get the values of x, y and z. So you can use the same method that we have done today. Okay, so these are your homework. Okay, so this much is for today. So in the next class we will do more problems on this solving by inverse matrix method. Okay, so you can copy it.